This is section 7.3. Our objectives for today are the student will be able to simplify rational expressions, multiply rational expressions, and divide rational expressions. So remember, rational expressions are simply a fraction. Anything that can be written as a fraction. So rational expressions today, what we're going to be working with is a fraction whose numerator and denominator are non-zero polynomials. So a simple rational number would be like 2/3. But now we're going to have like 2x plus 3 over 3x minus 2. That would be a rational expression where we have a polynomial in both the numerator and the denominator. The reason we have to say non-zero polynomials is because, remember, our denominator cannot be 0. So, the rational expressions again. A fraction whose numerator and denominator are non-zero polynomials. The domain of the rational expression excludes the values that make the denominator 0. So if we go back to this, if we have 2x plus 3, then our domain would be x cannot equal to negative 3 halves, because that would make the denominator 0. Remember, you can't divide by 0. In simplified form, it's in simplified form when its numerator and denominator have no common factors other than 1. So in other words, we're going to reduce them. Just like you have 4/6, we're going to reduce that to 2/3, except we're going to be doing it with polynomials. So nothing changes except how it looks with our normal rules for fractions. So our core concept is simplify rational expressions. Let a, b, and c be expressions with b not equal to 0 and c not equal to 0. And again, that's because those are in the denominator. And all we're doing here is the simple fact that we can cancel. If the same factor is in the numerator and the denominator, we can cancel those to reduce it. And that's what we'll be doing today. So if we go to this first example, 15 over 16, now there's a couple ways you can do it. You can factor it, and factor that into 5 times 3, and this into 5 times 13, and then we can cancel the 5s and get to 3 over 13. Or you can just say in your head, oh, 5 goes into 15 3 times, and 5 goes into 65 13 times, and go directly to that. So you don't necessarily have to factor it. When you get to expressions, again, these are already factored. There's nothing to factor on these. But we're looking for factors that are the same in both the numerator and denominator. And what you have to remember is you can only cancel 1 for 1. And so on top we're left with 4, and on the bottom we're left with x plus 3, and we would be done. So, steps to simplifying rational expressions. First of all, you want to factor the numerator and denominator. Now, remember, to factor polynomials, we check for greatest common factor. We can use the x method, or we can use the shortcuts that you've had before. We did these earlier in the year. So, remember the shortcuts, a squared minus b squared is the difference of two squares. That factors into a plus b and a minus b. A perfect square, a squared plus 2ab plus b squared factors into a plus b squared. And the same thing if it's minus, it factors into a minus b squared. And then we had our rules for the sum of cubes. Remember, it's a plus b, and then a squared minus ab plus b squared. And if it's a cubed minus b cubed, it's a minus b and a squared plus ab plus b squared. And then remember, if there's more than 3 terms, you look to group it. Then you should list restrictions. That's what makes the denominator 0, because we can't divide by that. So if we went back up to this problem up here that we just did, our restriction would be x cannot equal 3 because it makes the denominator 0. I like to do it before I cancel anything. That way I don't forget to make a list of something. And then you cancel the like factors that are located in the numerator and the denominator 1 for 1. So you can't, if you have x plus 2 and another x plus 2, and they're both in the numerator, you can't cancel those. You can only cancel if it's in the numerator and the denominator, and you can only cancel 1 for 1. All right, so now let's look at some examples. So they ask you in this case to example simplify x squared minus 4x minus 12. So that's x squared minus 4x minus 12 divided by x squared minus 4. So again, the first thing we do is we factor that. So that factors into x minus 6 and x plus 2. Again, most of you are used to doing the x method. This is a difference of two squares. So that factors into x plus 2 and x minus 2. Remember, the second step is we're going to list our restrictions. Now again, this is only the denominator. So x cannot equal negative 2 or positive 2. And then lastly, we cancel the like factors, x plus 2, and we're done. Our answer is x minus 6 over x minus 2. One thing to make sure I get all the time, people want to cancel the x's. You can only cancel things if they have something add or subtract to it if you cancel the whole thing. So that's why I like to put parentheses around anything, so you know you can only cancel if you cancel the whole thing. So what I'd like you now to do is go ahead and pause the video and try these four problems, these monitoring progress problems, and then come back, I'll go through them, and you can check to see how you did. So this first one is already factored for us, so I'm going to go ahead and list my restrictions. X cannot equal negative 1 and negative 3, and then we cancel our like factors, and so we end up with 2 over x plus 3. The second one, I can't factor this, so here's a good habit to get into. If I can't factor something, put parentheses around it. X squared minus 16 is the difference of two squares. So that factors into x plus 4. X minus 4, so my restrictions would be x cannot equal negative 4 or positive 4. Cancel like factors. Now if it cancels on top and there's nothing left, it just doesn't eliminate. That would be a 1 on top, and then on the bottom I'm left with an x minus 4. I see all the time people will cancel this. Since there's nothing up there, they'll just write x minus 4 as their answer. The third one, it's already factored. So our restrictions would be x cannot equal now. What makes x equal to 0 would be 0 and 2. And in this case, there are no factors on the top and bottom the same. I can't take 2 into 4 because it's got something added or subtracted to it. So that should have been just 4 and then x times x minus 2. And you're done. So there's nothing to do on that one. This last one, I'm going to factor the numerator. Again, you'd be doing the x method, but that's x minus 3, x plus 1. Factor the bottom, that would be x minus 3 and x plus 2. My restrictions would be x cannot equal 3 or negative 2. And then I cancel it. And so my final answer is x plus 1 over x plus 2. Again, I like to do the restrictions before I do any canceling because then I don't forget, because it's gone, but it's still a restriction from the original problem. Now, we're going to multiply rational expressions. So if you remember when you multiply fractions, you multiply straight across the top and straight across the bottom. So, advice, simplify and then write as one numerator and one denominator. So in this case, we've got these two fractions multiplied together. Now there's a couple ways you can do it. The book would go ahead and multiply this all together. So I'll show you how the book would do it, and then I'll show you how I would do it, and you can decide. So they would go 8 times 7 is 56. X to the third times x to the fourth is x to the seventh. Remember, you add powers, and y times y to the third would be y to the fourth. And then 2 times 4 is 8. And then x, and then y squared times y is y to the third. So they would do that first, and then they would simplify. And they would say, okay, 8 goes into 56 7 times. X to the 7th divided by x, you'd cancel 1, and you'd have x to the 6th left. And this would cancel 4 minus 3 would be y to the first. And And so we get y to the first, and our answer would be 7x to the 6th y. Our restrictions would be x cannot equal 0 and y cannot equal 0, because we have an x and a y in the denominator. So that's one way to do it. I personally prefer to go ahead and cancel first. You don't have to multiply this stuff together to cancel it. You can just say, well, is there anything that goes into 8 that goes into 2 or 4? Well, 2 goes into 8 4 times, and then 4 goes into 4 once, so those cancel. And then on top I have, on the bottom I have 1x, and on top I have 7x's. So I'm going to cancel 1 for 1, so this is going to become a squared. And then I have 3 y's on the bottom, so that will cancel 3 of the y's on top. And so then what I'm left with is 7. X squared times x to the 4th is x to the 6th. And a y. And I'm done. So whatever way you think is easier for you to do, by all means do it that way. It won't really make any difference once you get into the more complicated ones. So if we look at this one, so remember what we're going to do is we're going to factor this first. So this is why I like to do it this way, is to go ahead and make sure it's easier to work with. So we're going to factor this. So I'm going to take and factor the top. So I can pull a 3x out of that. And I get 1 minus x. And if I factor the bottom factors into x plus 5 and x minus 1. And this one, the top factors into x plus 5 and x minus 4. And I can't factor the bottom, so I've got 3x. So let's list our restrictions. X cannot equal what makes the denominator 0. Negative 5, positive 1, and 0. So those are my restrictions. And now we cancel like factors. So in this case, now the 3x, you don't have to, I've got a 3, cancels the 3, because those are multiplied together, I can cancel parts of them. X cancels the x. X plus 5 cancels the x plus 5. Now here's where you can be careful. We have 1 minus x and x minus 1. Those are not the same, so you can't cancel them. But they are opposites. So what I can do is pull out a negative 1 and flip that around and make it x minus 1. Because negative 1 times x is negative x, and negative 1 times 1 is a positive 1. So that's the same, it's just different. And now those are the same. And so I can cancel the x minus 1s. And so on top, I'm left with negative 1 times x minus 4. And everything canceled on the bottom, so that would be my answer. Now the book might write that as negative x plus 4 by distributing the negative sign through. So negative x plus 4. But you don't have to. You can write it that way. But if you're typing in the computer, they may ask you to do it that way. Let's look at this last example. So now we're going to factor. I can't factor the x plus 2. So again, advice, put it in parentheses. Only cancel it now if you can cancel the whole thing. X cubed minus 27. Well, 27 is 3 cubes, so that's the difference of cubes. So that factors into x minus 3. X squared, and then that would be plus 3x plus 9. And this one stays the same. That doesn't factor. There's no factors in 3 that have 3. So, one restriction would be x cannot equal 3. The other one would be, I would just put on this case that it can't equal I would just do that. I wouldn't go ahead and do the quadratic formula. I don't think it asks you to do it on these. All right, and now we cancel like factors. The x squared plus 3x plus 9 cancels. And so I'm left with x plus 2 over x minus 3. You don't have to have the parentheses, but you can. Up to you. So go ahead and pause the video. I've got 3 of the MPs for you to try, monitoring progress. So go ahead and pause the video. Try these, come back, see how you did on them. So on this first one, again, you could multiply this all together if you wanted, but what I'm going to do is simply reduce. I'm going to start with a 3, and 3 goes into 9 3 times. And then I've got a 6, 2 goes into 6 3 times, and 2 goes into 8 4 times. And then those 3's cancel. And now on top, so on top I have 6 x's, and on bottom I have 4. And so that's going to cancel all the x's on the bottom and leave me with 2 left on the top, x squared. And then I have 4 y's on the top, and I have 2 y's on the bottom, so 2 of these cancel 2 of those. And so I'm left on top with x squared, y squared, over 4. So that's what you should have gotten for that one. On this one, I'm going to factor the top, 2x, pull out the greatest common factor, and that gives me x minus 5. X squared minus 25 factors into x plus 5, x minus 5. Can't factor x plus 3, so I'm going to put that in parentheses. And then I can't factor 2x squared, so I'm going to do that. Cancel like factors. I have a 2. Again, I can do that because it's nothing's added or subtracted to it. I can cancel 1x for 1x. I can cancel an x minus 5 for an x minus 5. I have an x plus 3, none on the bottom. So I'm left with x plus 3 over x times x plus 5. Again, if you want your restrictions, x cannot equal negative 5, 5, or 0. Okay? This last one, x plus 5 doesn't factor. X cubed minus 1 does factor. It's a perfect cube. The difference of 2 cubes, so x minus 1, and then x squared plus x plus 1. Again, cancel that. So my answer is x plus 5 over x minus 1. Now, division. Remember when you divide fractions. 2/3 divided by 5/2 becomes, the first fraction stays the same, and you change it to multiplication and flip the second fraction over. It's a multiplication problem. Same thing happens with these. To divide rational expressions, multiply by the reciprocal. So nothing changes. We're going to do it the same way. We're going to factor this. Pull out a 2. Now, when I write these down, I just switch it as I write it down. I don't care when you do it, but this is going to flip over. So I'm now going to factor this, change it to multiplication. I'm going to factor this and put it on top. X minus 6, x minus 5, and factor that. I can pull an x out. So it's factored. Now, when you do restrictions here on division, you have to do anything that was ever in the denominator. So I would have to say that x cannot equal 5, it cannot equal 0, it cannot equal 6, and it can't equal 6. We already have that. It can't equal 5. I already have these, so I don't have to cancel it and do anything else. But that would be my restriction. Cancel like factors. I have a 7 on top, no 7s in front there. I have an x, 1 for 1. I have an x minus 6, and an x minus 5. And so I'm left with 7/2. So that would be my final answer, would be 7/2. This one, example 6. So I'm going to factor the top. That's going to factor into, let's see. So that's going to factor into 2x plus 5. just check that. 6x squared, yes. Excuse me, that would be minus 3. Now, you guys would be doing the x method on that, and then you would have to do the box because that's not a 1, so you have to remember that. But always check it. 6x squared, negative 9 plus 15, that's not. Oh, this should be a, sorry, this should be a 3x plus 5. 9, 10, oh, okay. So a 3x plus 5 and a 2x minus 3. Let's check that. So 6x squared, yes. Minus 9 plus 10 is a plus 1 minus 15. So that's why it's good to check. Can't factor that. I'm going to change to multiplication and flip this over. Since there's nothing here, it's a 1. So 1 goes on top. And I can pull just an x out. And I get 3x plus 5. So our restrictions in this case would be x cannot equal 0. This is a 0, and then this is a negative 5/3. Okay? Like factors, just start here. I have a 3x plus 5. I have a 2x minus 3, no 2x minus 3s, and a 1, so that's it. And so I'm left with on top, 2x minus 3 times 1 is 2x minus 3. And 4x squared times x would be 4x cubed. All right? So now, if you would try, again, pause the video, try these two, and then come back and check and see how you did. So, factor, I can't factor 4x. I can pull a 5 out of that. Change it to multiplication. Factor this and flip it over, so I can pull an x out of that and get x minus 2. And on this, it factors into x minus 4 and x minus 2. Our restrictions would be x cannot equal 4, 0, and 2. And then we're going to cancel. I've got an x I can cancel. I've got an x minus 4 I can cancel. I've got an x minus 2 I can cancel. And so you should have gotten 4/5. And then this last one, again, you would have to do the x method. Negative 10 and 3. And so that would be 5 and negative 2. But then you'd have to build the box because our a is not 1. So 2x squared, negative 5, 5x, negative 2. So that would be x minus 2 and 2x plus 5. Again, take the time to check it. 2x squared, yes. Oh, this should have been, see, it's a good reason to check. That should have been a minus 1. Nothing goes into those. That's why we want to check it. So 2x squared, yes. Negative 2 and positive 5 gives me a positive 3 and then negative 5. So I know I've got it right. 6x times, put a 1 underneath this, 1 on top. Can pull an x out of that. So x and then 2x plus 5. Our restrictions would be x cannot equal 0. And there's another 0 and then a negative 5/2. Remember, it's the opposite of this divided by that. Or set it equal to 0 and solve. Cancel, I've got a 2x plus 5. I have an x minus 1, no x minus 1s, a 1. And so I'm left with x minus 1 on top. And then 6x times x would be 6x squared on the bottom. So hopefully that makes sense. We're putting together our work with polynomials with work with fractions that you should know. So your assignment is on page 380, numbers 3 to 19, the odds, and 27 to 37, the odds. Make sure to state the restrictions.